The Dynamix from Make Noise is a versatile low-pass gate module derived from the popular zero-code synthesizer. It offers two independent channels, each capable of accepting audio or voltage sources. The CV controllable level parameter transforms both the amplitude and frequency content of a signal, making it suitable for use as a fast-responding VCA or a gentle low-pass filter. The Dynamix also features an additional input used for converting audio signals into control signals. These control signals, along with a bipolar attenuverter, can be used to generate various types of dynamic processing effects, such as compression, expansion, sidechaining, or ducking. The sum output provides a combined version of the two channels, along with an auxiliary input, making the Dynamix an efficient and expandable mixer as well. To begin, I'll set the input to its minimum value, fully counterclockwise, and the level knob to its maximum value, fully clockwise. The centrally located bipolar attenuverter should be set to its 12 o'clock position. I'll patch in a simple sustaining synth sound to the input of channel 1, the output of which is patched to a mixer. As I slowly increase the input level, you'll begin to hear the sound. When the control is set to approximately the 1 o'clock position, the input signal should be at or about unity gain. Turning the control further to the right will add gain to the signal. Anything past the 3 o'clock position will begin to overdrive the circuit. The impact of this overdrive can range from subtle to extreme, depending on the setting and the source material. At this point, without anything patched to its CV input, the level knob acts as a simple manual control. Turn the knob to the left, and the audio will begin to decrease in amplitude, much like a traditional VCA. But the Dynamix is not, strictly speaking, a traditional VCA. It's a low-pass gate, which means that as the amplitude of the signal decreases, a simultaneous reduction in the high-frequency content also occurs. The sound of this tonal transformation could be roughly equated to the sound of a gently sloping, non-resonant low-pass filter. I'll now patch in a sequence synth voice and inject an envelope into the CV input paired with the level parameter. Now the level knob becomes a unipolar attenuator to manage the incoming control voltage. The Dynamix is extremely responsive and is more than capable of handling even the fastest control signals. Audio rate signals can also be used. I'll replace the envelope with the output of an oscillator. This allows the Dynamix to be used for amplitude modulation synthesis, also known as AM synthesis. It's an effective technique for creating a broad range of unusual timbres. I'll switch back to the envelope signal and change the output routing so that the first channel now feeds the second. Cascading the two channels further expands the signal shaping possibilities. For example, I can now add 2 stages of overdrive for a more aggressive tone. Or I can add another external modulation source. Sending an LFO to the level CV input of the second channel creates additional movement to the sound. At any time, I can incorporate another audio source, such as this kick drum pattern, to the auxiliary input. It can now be heard, along with a mixed version of the individual channel outputs at the sum output. I've used a multiple to duplicate the kick drum audio and will now use it to demonstrate the dynamic control feature. Audio signals sent to the dynamic input are analyzed, smoothed out, and converted into a control signal. This control signal will be added or subtracted from the level depending on the setting of its associated bipolar attenuverter. At its center position, the control has no effect. Turning it clockwise in the positive direction will add the dynamic control signal to the level. Now the level increases each time the kick drum hits, causing the sequence to pulse in time with it. Turning the attenuverter to the opposite side will create an inverse reaction. Now the kick causes a reduction in level, resulting in a pumping effect, commonly known as sidechaining or ducking. It's important to note that the dynamic input is normal to the channel's input. So if I remove the kick drum audio, it's the synth sequence that is now analyzed and converted into the control signal. Adjustments to the attenuverter now create compression or expansion type effects. Because of this normalized signal path, the attenuverter should be returned to the center position to remove any unwanted impact of the dynamic parameter. The Dynamix's inputs can also accept control voltage, so it's possible to use all of these techniques to process CV signals. For example, you could use the Dynamix to attenuate the level of an incoming LFO to manage the depth of its modulation power. Or modulate the level of incoming triggers on one channel and send them to the dynamic input of the other channel. This could create accents in an otherwise static pattern. Although its design originates from the Zero Coast, the Dynamix manages to stand apart from its predecessor by providing an expanded feature set and enhanced functionality.